Hi everyone, my name is Thomas Kim. Today is February 19th, 2019. This is my 8th episode about C++ type function, modern C++ programming. And this is also second episode about all about std forward. This is our previous session. In this session, we will learn how to implement std forward. That is, we will implement std forward in this session. To completely understand the std forward, we need to know what is non-deduced context, and we will also need to know what is remove reference t, this type function. We will also implement std remove reference t in this session. First, about non-deduced context, template metaprogramming 15, episode 15, non-deduced context in C++, I explained in this session. I will explain in detail about non-deduced context in this session too, but if you want to have more deep understanding, then please refer to this video. Also, we need to understand how to remove reference t about this function. In my episode 19, Decipher standard template library, in this video, I explained how to implement remove reference t. Also, in this session, I will explain how to implement remove reference t. But if you want to know more about the deep understanding, please refer to this video. We also need to understand reference collapsing rule. If we want to understand std forward, we need to understand reference collapsing rule. Please watch this video. In this video, I explained what is reference collapsing rule. I will explain about reference collapsing rule in this session too, but I hope you watch this video as well. We also need to understand noexcept keyword, how to use noexcept keyword. Please watch this video. In this video, you can learn more about keyword noexcept, and also watch this video about noexcept. In this video, I explained how to use noexcept in C++ programming. Anyway, I will try to explain all 4 items in this session. This session continues from my previous video, episode 7, all about std forward. We need to move forward. Please click this link, download the source file, our previous source code, by clicking this link. Show in folder. Please unzip the file. Double click, copy this folder. Paste it to your working folder. Double click the folder, copy the folder path, right click your command prompt, right click once again, property, click in starting folder, Ctrl A, Ctrl V, then click OK. Start Visual Studio Code. File, open folder, paste the folder, Ctrl V, select the folder. Let's see what we will learn in this session once again. Basically, we will implement std forward. To implement std forward, we need to understand non-deduced context, std move reference t. And then we need to understand reference collapsing rule. We also need to understand how to use keyword noexcept. And there is one thing more. We need to understand how types get deduced, how types get distorted. We also need to know how types get distorted, how types get deduced when the parameter passed from one function to another. I will start this session with item 5 first. In Visual Studio Code, this is our previous session. I will create one file, implement cpp. Include pch.h. void function, I would say fun, int reference a, auto stream talk play fun stream auto nl stream get console out, constant character pointer msg stream msg int reference a nl. I create another function. This is now R value reference. Void test parameter distortion. int main. From this function test parameter distortion, int a, I say b5, int r5, int l, l value reference l, b. So from this function, test parameter function, I am going to call this function. These are overloaded. How these two functions, how these parameters are passed, you have to watch carefully, okay? Now let's do like this. FNC fun b int b5 b. Okay, once again, fun int l value reference l b b. We are passing b l. Now once again here, fun int r value reference r 5 r. Now we call this function in the command prompt. dir cd 07 forward. We need to compile precompiled header first. pch local pch cpp. Now we build the function, our program, msbc local implement cpp m. Now watch it carefully. Please note that we called this function fun b equal 5. This function is called. Okay, this intb, this reference function is called L value reference. When we pass the L value L, also this function is called this function. With R value reference R, this function is also called. Even though we passed R value function R to these two function overloading, the function, this L value reference parameter A, always this function is called, because this parameter B, L, R, B, L, R gets distorted. In C++, when a parameter is passed to another function, the type of the parameter gets distorted. Okay, now I make another function. I disable this void test std forward. Now intb 5 function std forward int a, std forward int a. Now once again, int L value reference L v function std forward int L value reference b std forward int L value reference L int L value reference R5 fun std forward int R value reference R std forward int R value reference R. Okay, I will make one more function call here. Like this, and I will also make it one more call here. R value reference, R value reference. I will remove this part. Now we test this function. Now if we build this function will be called it is not A, it is B. It is L. Okay, it is B. Now if we run it, so this function is returned as pure R value. This is R value. This is R value. And in this function, second function called this call, this is also R value reference. In third call, this is L value, this is L value reference. L value reference, this function is called. And in this function, this is the case R value reference, STD port, also R value reference. I will talk about this very shortly. This amounts to reference collapsing law. I will talk about it just a few minutes later. The purpose of STD forward is to prevent this type distortion of the parameter while passing from one function to another. Okay, so it is named forward, to forward the parameter to another function without type distortion. Okay, I covered item 5. We need to know how types get distorted, how types get deduced when the parameter passed from one function to another. I will talk more about this part very soon. Now I am going to talk about this function first, std remove reference, this one, item second. Now let's implement. By implementing remove reference t, we can better understand what it means. Template, type name t, struct, remove reference, I say st. This is primary template. Primary template determines the count of parameter. I explained this fact several times in my previous videos. Now second, specialization, template, type name t, struct. In this case, we can have default values like this using type t. Okay, t is neither L value reference nor R value reference. Now in this case, remove reference st, we give specialization t L value reference. Okay, when the parameter is L value reference, then using type t. Okay, the parameter is L value reference means t reference. This is if this is L value reference. For example, if t equals int, then t reference becomes int L value reference. I hope you understand this concept. Okay, why this is L value reference. Then we we remove reference part and we assign only t like this. Don't forget semicolon here. This is called partial specialization. Partial specialization, or just specialization, no problem. Template, type name t, struct, remove reference sd. Now this is r-value reference. Okay, when the parameter is r-value reference, in this case, if t equals int, then it becomes int r-value reference. In this case, don't forget semicolon here. Using type t. Okay, so the highlight is here. Template, type name t, using remove reference t. We are calling this struct like this, t. Each struct has member type t, this type. Don't forget type name here. Type name. Okay. Then we are testing this function. This function. Now say void test remove reference. We are testing this type function. These are called type function. INTA 5 int l value reference l a r value reference r 5. Now we display each type like this. Stream type of a, talk, play, fun, get type category a. Okay, it returns a type category. Now here once again, stream type of l, talk, play, fun, get type category l. Stream type of r. Okay, talk, play, fun, get type category r and l. Now I hope you understand this concept. Now we will call this function okay. So I will call two more functions like this. First, I will copy this part. Now we remove, okay, remove reference t. I will call like this. In this case, we have to call, no, we will call this remove reference t. We have to provide type here, int. Then we say type name. Then we have to provide type name like this. remove reference t int. It removes reference from this type int. Now I copy this once again from here. Now this is L value reference, like this. Then I copy here once again R value reference, like this. Now we test this function. Say first type of A is int. Remove reference t. Sorry, I have to use this, so I have to remove s. Try again. Remove reference t. Undeclared identifier. Remove reference t. Okay. Okay. So remove reference t removes from int, removes reference. Remove reference t from L value reference, it removes reference, then it becomes int. From R value reference, the result becomes int. So remove reference returns type t. Okay, it removes reference. So up to this point, I covered this part. Now let's move to this part, non-deduced context. Now let's talk about non-deduced context. Non-deduced context is what std forward makes difference from std move. Both std forward and std move are type cast to R value reference, but std move blindly typecast to R value reference, whereas std forward typecast to R value reference smartly. Now let's understand what is non-deduced context first. Template, type name t, struct, dummy, struct. I will make it primary template. I make specialization, type name t, struct, dummy struct, double, using type int. This is specialization. In this case, I don't think I need t here. Template, struct, dummy, struct, int, using type int. Okay. Primary template determines the parameter count. T equals double. In this case, T equals int. This T comes from primary template parameter T. Now we are making a function template type name T void call non-deduced context fun dummy struct T. It has member type reference D. We have to prepend the type name here because of this type. Stream call non-deduced context fun is called NL void test non-deduced context. I declare int a5 int r value reference r5. Now we are calling this function like this, call non-deduced context function A. Please note that the type of A is integer. In this function, dummy struct type is integer. It is integer. So this type is integer reference of D. So it should be workable, callable, but it doesn't work. Let's compile. I will copy this function name and paste it here. I disable it. See the message carefully. Here, void call non-deduced function could not deduce template argument for T. Template argument cannot be deduced. Now let's examine why. This is type is int in both cases. Let's think about the T. In this case, T is double. In this case, T is int. Both type is int. Using this type, C++ compiler cannot determine type of T. This is so-called non-deduced context. C++ compiler cannot determine the template argument for T, cannot determine the type of template parameter for T. It conflicts from this type. Even though this type is both int, this type T cannot be determined. It can be double, or it can be int, or anything else. If we want to resolve this issue, we have to provide the type of T explicitly. For example, int. We have to explicitly provide the type of T. Now let's build if it works. Okay, it works. Now this works. This message is displayed. Or we can also pass call non-deduced context double R. It should also work. It also works. This non-deduced context plays an important role for STD forward. Now let's think another way. This template type name T using dummy T dummy struct T type name. I copied this part once again and I disabled this part and I copy this like this and T. I modified like this. I remove this. It still does not work. It still does not work because this is just type alias for the dummy struct type. It does not work. Now let's think about remove reference T. Template type name T R value reference forward remove reference T B return static. I would just say T reference. I will look simple. B. This is simple typecast. Void test forward int A5 int R value reference R6. We are calling this function stream forward called NL. Now we are calling this function from here forward A forward R. We are calling this function from main function main like this. Since it doesn't work, I will fix it. int double. Now let's compile it. Forward no matching overload could not deduce the template argument for T. 88. This does not work because when this function calls this function, the type of T, this parameter T cannot be deduced. Now we can pass like this, int. Now it can work. Now it works. So we have to provide type explicitly. Well, I will copy this part, paste it, disable. Then I can copy this part too. Copy. This and this is exactly the same. Now if we remove this part, it does not work. It does not work. We have to provide a type here. Then it will work. This is what is called non-deduced context. In case of standard C++, it is done like this: static cast like this. I will disable this part, enable this part, because they are the same. Cut and paste here. Please note that this function is not enough. This is L value. B is for L value reference. So this does not work. Forward int 5. Call forward with pure R value. It does not work because we have not defined R value, reference parameter of forward function. Now let's build. No, it does not work. So copy once again, paste. This is for R value reference. Now it should work. In C++, standard, a few functions are marked with keyword noexcept. Functions marked with noexcept should not leak exceptions. If those functions marked with noexcept leak an exception, then the program crashes. For more about keyword noexcept, please refer to this video. So it should be marked noexcept, and here too. In this typecast, exception does not leak. So it makes sense. Up to this point, I explained this part, and I explained this part, and I explained this part. 6. Now 2 things left. Reference collapsing rule and how types get deduced when parameter passed from one function to another. Now let's take a break. Please pause the video because reference collapsing rule and this parameter type deduction is quite challenging. Here, template, type name T, void the forwarder T, B, void the caller. In this the forwarder function, we have to think 2 things. The template parameter T, the function called parameter B. For your reference, template type name T, void func PARAM, constant T, reference B. In this function called parameter T and B are not forwarding reference. If template parameter is T, this case T, this template parameter T, the function called parameter type should be T reference. Constant T reference B is not universal or forwarding reference. Template type name T, struct my struct static void function T reference B. This T reference is not forwarding reference because this T is not the template parameter for function. This T is the template parameter for the struct my struct. Template type name S, static void OK forwarding reference S. Here S reference is forwarding reference because the template parameter type is S. The template parameter type for OK forwarding reference. I hope you understand what is forwarding reference, what is not forwarding reference. In this case, because of this constant, this t is not forwarding reference. In this case, t is not the template parameter for function. This t is template parameter for my struct. So in this function, t is not forwarding reference. In this case, s is template parameter for OK forwarding reference function. So it is universal reference or forwarding reference. ss is universal reference or forwarding reference. In the caller, we are calling this function like this: int a 5 int l value reference a int r value reference 6. Now we call this function constant character message stream msg talk play fun get type name t's type, this template parameter type. I will say type of t, type of b, talk play fun, get type category b, nl. Watch it carefully. The forwarder INTA 5 A. The forwarder INT L value reference L A L. The forwarder INT R value reference R6 R. The forwarder pure R value 6, I would say 7. I will create another function int return pr value, return 8. The forwarder return pr value, return pr value. Now we are calling this function, we are testing this. Copy, paste. Now we are calling this the forwarder function. I will put a comma here. I will rebuild it. Please note this case, R-value case. Okay, R-value case is R-value reference. Pure R-value, return PR value, R-value reference. I will summarize this result here. When local int is passed, this type is int L-value reference, this type is int L-value reference. Let's check once again. L-value reference, L-value reference. int L-value is passed. T is L-value reference. B is L-value reference. Okay. int R-value reference is passed. T is int L-value reference. B is int L-value reference. Here, please note this line very carefully. We pass R-value reference. This type is L-value reference. This type is L-value reference. Especially careful about this line. Now, PR value int5 is passed. T is int. I would say PR value 5. Please note that this type is int. This type is int. And this type is int R-value reference. Understanding this step is very, very important. When return value is passed, for example, A, this function returns A. The type of T is int. The type of V is int reference. Please watch this line carefully. This is the summary. Now I am talking about reference collapsing rule. C++ standard says that for any type T L-value reference combines with R-value reference, then collapse T L-value reference. What it means is something like this. Static cast int L-value reference, R-value reference, B. The result will be int reference, static cast B. T R-value reference means L-value reference. It collapses to T L-value reference. For example, static cast int r-value reference l-value reference b is equivalent to static cast int l-value b. T r-value reference means r-value reference, T r-value reference, static cast int r-value reference b is equivalent to static cast int r-value reference b. Finally, T l-value reference meets l-value reference decays T l-value reference. For example, static cast int l-value reference b static cast int l-value reference b. All you need to remember is this line, so you can regard l-value reference as 0, r-value reference as 1. L-value reference times r-value reference 0 times 1 0 means l-value reference. r-value times l-value 1 times 0 l-value reference. r-value times r-value 1 times 1 r-value reference. l-value times l-value 0 times 0 l-value reference. These are that famous reference collapsing rule. Now I am scrolling up. I am copying forward function. I pasted it here. You do not need to concern about this part now. From now on, this part does not matter. So I will delete. What you need to concern is this part. Now I copy this table again. I paste it here. Now you do not need to concern about this. Now I apply this rule. I copy, paste. I make room like this. I copy once again. Here. This is int. In place of t, this is int. In place of t, this is int. In place of t, this is int. I paste it here. This is int. Here. Now let's think about this. Applying this rule, this is exactly the same state. then it becomes like this. I will copy like this. This line corresponds to this line, so I copy it here, and this line is also the same. And in this case, this is this, also the same. This is what std forward does. Please note that when L value is passed, T's type becomes like this. If we apply this rule, this is T, and we replace T with this value here, this value here, this value here, int here, int here. If we substitute the type of T in this equation, in this typecasting, these are all L values. L value, reference, L value, reference, L value, reference, R value, reference, R value, reference. So the last two cases is R value reference. What it means is that if we apply std forward T B means talk, play, fun, get type category, and L. Now we are applying this rule, std forward T B. So we are applying this rule, and this function. Now we call this function once again forwarder, the caller. I will make one more changes here, like this. Now we are compiling again. M. Now compare. We pass int a, the type becomes T. Now let's compare with this and this. This is L value reference. A's type is L value, so it gives L value. L's type is L value, so it is L value. This is also L. This is also L value because we haven't casted, we haven't forwarded here. This is L value originally. L value. In this case, this turns T becomes, we are passing pure 7. This line of code. This line. The type of B becomes R value reference. If we apply forward, it preserves the state, the same state. Why we need it? I explained why we need it in our previous session. I will show you once again why we need. Without using this, we have sometimes problem. I am creating another function, template, type name T, void, the forwarded. This is the forwarded constant character message T B. This is the forwarded function stream in the forwarded we are displaying the type of B. Talk play fun. Get type category B and L. Now we are doing some experiment. Here the forwarded we are passing the same message, then B. We are not applying std forward. Okay. Now we build M. Let's see. The caller calls the forwarder A L R 7 return value. This forwarder takes the parameter B. Then the forwarder gets value like this. R value reference distorted to L value reference. R value reference in the forwarder, R value reference in the forwarder becomes L value reference in the forwarded. Now let's see. The forwarder forwarded MSG std forward T B. Okay, we are now forwarding. Here I disable this part. Now we build again. Please remember these two parts, last two parts. We rebuild. Please note that the forwarded, by introducing this std forward original state, this is from original state, R value is forwarded to R value. R value is forwarded to R value from the caller through the forwarder finally arrived at the forwarded. In this forwarding process, R value is preserved because this forwarder forwarded using std forward. So all you need to remember is this syntax. This explanation is to help you understand what std forward. In real programming, you do not need to remember these things. All you need to remember is forward with this syntax. That's good enough. Let's take a break. Then I will give you very important application of this STD forward. After a break, I will give you really important usage for this STD forward. Now I will give you concrete example. STD forward has two very important applications. One, to recycle R value or X value. Second, to forward parameter from one function to another. About recycling R value, please watch my previous video or the previous video. int R value reference sum int R value reference s constant int t. Please note that this is R value reference. It is returning R value reference, so we can recycle s like this. Then we are returning, we have to forward like this s. If we don't forward like this, this is L value in this function, s is L value inside this function, we have to forward like this. Then template, type name, operation type, type name s, type name t, decl type auto, forward it, operation type, operation s R value reference s, t R value reference t, return operation. We are forwarding this parameter s to this sum function like this. Forward s s, std forward t t. Okay, now we will create a function void test forward it please. int a5 int r1. We are calling this function like this indirectly. Forward it. We are passing this sum like this. Then the first parameter we will have R value, for example 10. Then the next one we will send this parameter a. Then we print out a string r1 equals r1 and there. Now let's build and test. We have to call this function from function main. Okay, 15. Please note that we passed R value to this function with sum as a function operation. So this sum becomes operation in this function, and forwarded forwards both 10 and a through forwarding references s and t like this way. Since we sent 10 as pure R value, this becomes pure R value. R value is preserved. Now I will give you another example. intr2 forward it. Now we are using lambda. intr value reference s, constant int reference t. Here we do the same. Return std forward int, we can do like this, s. Then we have to pass parameter. This is lambda. We have to pass two parameter, s and t. So we will say 10a. Then we display stream r2 equals r2 nl. Now I build m. So in the second case, we sent the same value. We can pass like 20. Like this. I use this mechanism, forwarding mechanism, quite a lot. Not only me, lots of C++ standard library is built this way. I filmed about 370 videos so far. This session was the most challenging for me. For more details, please watch my previous videos about individual components. So to understand std forward, it takes a lot of effort. Please subscribe to my YouTube channel. Thank you for watching.